So, good morning, good afternoon, good evening, wherever you are in the world. Welcome to this session. My name is Gary Rueda Sandoval. I'm the co founder of TMMI America. I'm the CEO of Business Innovations. I'm the co author of the world first uh, Spanish language IS2QB software testing certification book. And I've spent 30 years advancing software testing uh, for across Latin America and beyond. And I'm thrilled to be your host today. 40 minutes, 35 minutes for the keynote, and 5 minutes for questions and answers. Please drop your questions in the chat as we go. And now I would like to introduce the speakers of today. Um, Rogerio Castillo, known as Roy, founder and principal of Caliche Energy Solutions. Roy would talk about talk us about a topic that is very front and center for all of us: testing in the age of AI. Roy, please, the floor is yours.
Thank you,
Welcome.
Rudy. Thank you so much. Well, thank you all for taking time to listen to this portion. I have a long history in test. As I started test groups for Compact Computer Company in the 90s, and they outsourced much of their work to me then, and all the way through the mid 2000s. I took a break from that, and then about 5 years ago, we started writing some software, and of course, what comes along with developing a new software product, and nothing but test. So this new company that we have, we have a product called Molecule Value Tracker, and it's all around the energy industry. And so, and about the time we started writing that software, of course, AI was gaining steam. We didn't do much with AI the first year or so, but about 4 years ago, we hired a couple of people who worked for us, and of course, I knew some about AI, but at a very high level. And then, of course, in the last 2 years now, we've been engrossed with AI testing because our product has an AI feature to it. And so, well, not only because it has the AI feature, but because AI has definitely lent capabilities for us in our company to do far deeper testing than we used to do at a very low cost. So that has been tremendously good and beneficial to us. So what I want to talk about is kind of the big shift, right, from what we called automated testing. I started when developing a meat grinder product for Compact back in the mid 90s, 94, 95. And of course, we tried to automate these tests to break hardware, and primarily it did. And so it brought forth the evolution as we got into 99 and 2000, where automated testing, true automation testing came into play. Well, so now, of course, we're in the state of AI, and how AI in the testing arena is so great for us. And of course, a lot of people think that AI is going to take their job, but if done right, AI does not take our jobs. Typically, what it will take is the stress away from trying to figure out the best test solutions that come about. And so we have a team of people that work for us, my business partner and I, and I think I heard Anu talk about this in her discussion about silent. Well, she talked about drift and she talked about hallucinations, but the one thing that we concern ourselves with is the silent logic drift. And so that can happen if if AI testing is not done uh, with differential testing when it comes to AI. And so also generative AI risk layer, right? I'm sure many of you have heard or thought or even worked with uh, this plan because AI writes code fast and it must validate it even faster. And so we've experienced this over the last couple of years with our product and with what we're doing. So first of all, I'm going to talk about um, as our introduction the evolution from traditional SDLC to AI augmented SDLC. And so for decades, the software development lifecycle followed a structured but structured heavily a manual workflow. Well, many analysts documented requirements, architects designed systems, developers wrote code, test engineers manually created test cases, automated scripts, executed regression cycles, and maintained them release after release. And that is work that is very important, of course. And so automation existed, but it was rule-based, brittle, and required constant human maintenance. Well, artificial intelligence has fundamentally shifted this paradigm. And I know I'm not speaking to you with something you haven't heard before, but hopefully you'll learn something from what I talk about. And so AI is not just automating tasks, it's understanding intent, learning system behavior, predicting risk, generating artifacts, optimizing execution, detecting vulnerabilities, and continuously improving quality loops. Testing is no longer a downstream validation step. In fact, it's becoming an intelligent, adaptive quality system embedded across the SDLC. So we'll get to the next heading, and that is AI at the beginning of the life cycle, from conversation to structured requirements. Well, so meetings that we have to meeting transcripts that we have to user story. Modern enterprises conduct requirement discussions in Microsoft Teams, Zoom, or collaborative platforms. And AI systems now capture those meeting recordings, transcribe discussions, extract key functional requirements, identify acceptance criteria, detect dependencies, suggest edge cases. And some of the tools in the market enabling this similar capability, Microsoft Copilot, meeting summarization and requirement drafting, Atlassian Intelligence, Jira AI story generation. I'm sure many of you use those, as well as Notion AI, ClickUp AI, and Zoom AI Companion. We have our team uses most of these tools. And of course, AI models use NLP to convert unstructured discussions into structured artifacts. One user story example: as a premium customer, we want to reset my password securely so that I can access my account without contacting support. Well, AI can auto-generate acceptance criteria, boundary cases, security considerations, negative scenarios. This reduces ambiguity, which historically has been a major cause of downstream defects. Now to our third point here: AI-powered architecture and code base intelligence. After requirements are structured, AI assists architects and developers. Well, code base understanding and delta detection. In large enterprises, code bases contain millions of lines, dependencies are complex, documentation is complete. AI-powered code intelligent tools analyze dependency graphs, call hierarchies, data flows, API interactions, historical defect density. Well, so what are some of the tools that are used? Well, GitHub Copilot Enterprise, SourceGraph Cody,
Hey
CodeSense.
Roy, quick
Yeah,
question. Are you
yes.
presenting? We're not seeing anything. Oh, if if it does not have a presentation, you're fine.
Oh no, I did not realize it. That is
That's okay. Can you
okay.
share your screen and then we can go ahead from there?
Absolutely. I
Thank
don't
you.
mind sharing. How can I share my screen here?
At the bottom, you can
I
see.
see it.
Yeah.
I see it. Sorry.
Thank you, sir.
Okay. Can everyone see that now?
I'm seeing a Word document. Is that the one you're present?
Yes.
Okay.
Yes, this is
Okay.
it.
Okay.
Sorry, guys. So as I said earlier, some of these tools that can be used, right, are GitHub Copilot Enterprise, SourceGraph Cody, CodeSense, SonarQube, AI-assisted analysis, and Snipe Code, Cast Highlight. And when new features are added, AI identifies the delta, which modules change, which services are impacted, which APIs are affected, and which data models are modified. This delta intelligence feeds directly to the intelligent test selection. And so I'm not sure how widely some of you use those tools, but in our company, they're used quite frequently in order to validate a lot of the code. So AI and test generation, from manual authoring to autonomous creation. We know what the traditional model is, right? Previously, testers manually read requirement documents. You have meetings after meetings after meetings to make sure that everything is correct, and then identified positive, negative cases, created traceability matrices, wrote scripts manually. Large enterprise maintained 10 to 50,000 regression tests. Maintenance effort often consumes 50 to 60% of QA capacity. Well, AI-based test case generation, this is what we have experienced. AI platforms analyze requirements, UI structure, API schemas, production telemetry, historical defects, and automatically generate positive scenarios, negative scenarios, boundary value tests, data-driven combinations, exploratory paths. Well, it is really phenomenal what our experience we found rather from our experience in using AI in testing. We found some not so great results and some very great results, but the net effect has been extremely positive in our doing this with our product. And so, in fact, we have I have some relatives who own a software company as well, and so we are lending our tools to them, and they have come back and said it has driven down their time to market with their small applications so quickly that they can't believe it. And some of the market leading tools that we use are here: Testim, Mabel, Functionize, Tricentis Tosca, Catalan platform, ExcelQ, Audify, LeapWork, Perfecto, and then some of the NLP test creation. Verify that this example here, verify that a premium user can transfer funds above 10,000 with OTP validation. Well, AI converts this into an executable Selenium, Playwright, or Cypress scripts. And so one thing that I didn't bring up earlier, and I should have, we have a long history with banking systems. And in the 90s and 2000s, we were testing migrations from mainframes, IBM mainframes primarily, to client server-based systems. And those processes that were on the mainframes we had to test, and it was so painful that it was excessively painful that everything had to be done manually and somewhat in an automated fashion. But because of here in the United States, the Federal Reserve regulations that we had to live under, it made it even more restrictive as to how we tested, and that was just so painful. If you can imagine banking systems and the regulation that they have, at least here in the United States. I know GDRP also came into effect several years ago, and it is something. It gives me a headache sometimes thinking about it. automated script generation and self-healing automation. AI translates users' action into Selenium or Java Python. Playwright, Cypress, WebDriver, IO, Appium, tools supporting AI script generation, test project, Worksoft. I'm sure I'm not telling any of you something that you don't already know, but this is what me and my team helped me come up with my presentation with some of it. And so I thought it would be useful for everyone. Self-healing automation, traditional automation fails when UI elements IDs change, DOM structure shifts, CSS classes update. AI-powered self-healing systems understand semantic relationships, use visual recognition, Apply tools, apply ML-based locator strategies, and some of those platforms, Mabel, Testim, Apply tools, Visual AI, Functionize. And of course, maintenance cost reduces dramatically. And so I'm not sure if any of you have seen those costs go down, but we in our software company have seen that cost go down drastically, which led to us not needing as many support personnel that we thought we were going to have to do to do some of the regression testing, which leads us here: intelligent regression optimization and impact-based testing. Running 20,000 tests per release is inefficient, right? Well, everybody knows that. Well, AI enables risk-based selection, predictive prioritization, change-based regression. Excuse me one second. Well, how does this work? It works. AI analyzes code differentials, dependency maps, defect history, production incident data, and even predicts high-risk modules, tests likely to fail, tests safe to skip, and the tools are launchable that we use: C-Lights, Harness Test Intelligence, and sometimes it's Tricentis Live Compare. And so we have found for us that regression execution time can drop 40 to 80%. And so that is the example that I was giving you, that we were able to save money for our product so that we didn't have to do as much. Well, we validated these numbers, right? And of course, sometimes it's 40%, but periodically we'll hit the peak of cutting down the time by 80% of regression testing. And so that's quicker to market for us as well, and that's very important for us. So deep dive into AI and application modernization testing. Gave you the example of mainframes before in the 90s, how it used to really, it was a high risk initiative that we took on, and we did about a dozen of those migrations from mainframe to client server systems, and it was extremely risky, and we had a lot of bumps and bruises, but it leads us to these scenarios: mainframe to cloud native, .NET framework to .NET Core, monolith to Microsoft microservices, on-prem to AWS, Azure, GCP, legacy UI, React, Angular, and mobile. And so these are things that that all have to be done today and delivered efficiently. And if not, as Anu brought out earlier, that we lose trust from our customers. And so even though our testing is very narrow on our application, because we're only testing our system with our data, of course, we sell our software and we don't test our system unless there's a problem with our customers' data. But it's really important that our customers see that our testing is done, because one slip up, and of course they lose trust. And we've been fortunate that I would have to say we've been fortunate in the fact that AI has helped us to become more lean and more deliver more. I hate to say perfect, because there is no software that's perfect, but we haven't had any bad situations that customers are like, hey, why didn't you do this? Or did you forget to test this? And so we've been very fortunate in the last year since we first delivered our software that we haven't had any issues as we all had with other software in the past. So I feel very fortunate there. Well, so next we're going to discuss these 4 layers: AI-powered modernization layers, legacy reverse engineering. Layer 1, layer 2 is business rule extraction. Layer 3, differential testing, and layer 4, continuous equivalence monitoring. And of course, this was called something else in the 90s, right? But now this is what we're doing. Let's start first with the layer 1, legacy reverse engineering. Tools we use: IBM Watson Code Assistant for Z, AWS mainframe modernization, Microfocus Enterprise Analyzer, Cast Highlight, and then of course AI generates call graphs, dependency maps, data flow analysis, and hidden branching logic. And this has been really useful for us, especially when we do have to migrate. In the past, customer systems, this was greatly useful. Layer 2, business rule extraction. AI extracts implicit logic such as if balance, 50,000 in account type equal premium, then interest bonus equal 2%. This is an example that we put in because we actually did this, and it is really really important that we have what is below here: boundary tests, combinatorial scenarios, edge case validation. And of course, these are some of the tools we use: Tricentis, Tosca, XLQ, OpenText UFT1, and Parasoft SOA test. And I have some examples here of differential testing architecture that we put together. And I'm sure it's nothing that you haven't seen before, but I'll go slowly here. And I don't mind sharing this with anyone or everyone if you like, but this is some of the things that we use in our testing for ourselves. And I didn't talk at the beginning or tell anyone this at the beginning of this. I have another company called AREIT Systems, and that's why I kind of bleed into the work that company does as well for customers. It's separate from this software company, but it's a IT services and outsourcing company based out of Houston here. And our group there uses a lot of these features as well. But in number 4 now, continuous equivalence monitoring. Well, I think this has been one of the biggest assets to both of my companies that were able to use these AI in order to do this selective equivalence testing, AI-based prioritization, and drift monitoring. And that's really our big concern, right, is drift monitoring. This prevents post-migration logic drift. And so we've seen how this helps us with our MVT product with Kalichi. And it's been very, very beneficial for us. Generative AI vibe coding and testing implications. So about a year and a half ago, our guys on our team started vibe coding. And when they first said it, I'm like, what is that? Well, of course, I know what it is now. And you know, sometimes if not careful, our team has said that it can be a problem, or it can create a problem, vibe coding it. And so they're very careful with what they're doing. And these are some of the tools that our team uses: GitHub Copilot, Amazon Code Whisperer, Google Gemini Code Assist, Tab9, and Replit AI. And then some of the risks that were introduced here: vulnerabilities, license contamination, logical flaws, and overtrust in generated code. And so testing must evolve alongside generative coding. And we have learned quite a bit of this in our experience now with Kalichi in the last year and a half. And so we're very excited, though, that vibe coding is going to help speed up the development of not only the product we have, but we plan to develop several other products for the energy sector that we're in. AI and security testing, DevSecOps integration, the security tools, Snipe, Checkmarks, Veracode, SonarQube, GitHub, Advanced Security, Aqua Security, Prisma Cloud. AI detects injection flaws, dependency vulnerabilities, hard-coded secrets, container risk, cloud misconfigurations, and security is now continuous, not just periodic. And this makes me unbelievably happy for what the product that we're building. Because when I would sleep at night in the past, before we started doing all of this testing in abundance, I worried at night that we missed something. And so, and maybe it's a false sense of security, but today I feel a lot more confident in our testing. And so, and I have to say that a lot has to do with the AI testing that we're doing on our product. Real world case studies. This we put in this on purpose. This was my situation that we put in. Banking mainframe migration. There was a large bank here in the United States that we had to do a migration. This was in the mid 2000s, quite a while ago, but it was the easiest case that I thought I could come up with. And so we had 12,000 plus regression cases, COBOL to Java microservices, AI-based rule extraction, and then 500,000 synthetic data validations. Well, today we know that the results would be 60% regression reduction. And so, and 35% fewer production defects. And so here's another, this is another one that we have. Insurance.net modernization, Testim and Apply Tools and Snipe, 85% automation coverage and 50% maintenance reduction. And then, of course, the third case study was retail microservices transformation, Mabel plus Cypress plus Launchable, 70% flaky test reduction, and CI and CD reduced from 2 weeks to 3 days. And so I know I'm not telling any of you anything you don't know, but it is a fundamental tool now. AI, using AI for test is I think a beautiful thing. It's not a beautiful thing, and AI is not a beautiful thing for every industry and every scenario, but in our industry, it is amazing. So here's a full AI testing ecosystem architecture that our guys use: requirements meetings, NLP requirement engine, code intelligence platform, test generation engine, UI automation, API testing, security scans, CI/CD pipeline, observability, and AI feedback. And then the repetitiveness of test is what really cleans everything out for us. And we're so happy that we have that ability, because the observability and then the feedback that we get is, and that's where typically that I'm involved with, right? With our team when issues come up, and then we go back to get the feedback through our AI tools that we use, and it's really changed the game for us. So we're very happy about that. And then here's some strategic industry takeaways: 40 to 80% regression reduction achievable, 30 to 70% manual effort reduction, faster time to market, predictive risk modeling, continuous security validation. And as I said before, AI is not eliminating QA roles, it's elevating them. And so the SDLC is becoming intelligent, adaptive, and self-optimizing. And that transformation is happening now. And so I'm a little early. I think I'm a couple of minutes early, but this is my takeaway right here. AI is not eliminating QA roles, it's elevating them, and the SDLC is becoming intelligent, adaptive, and self-optimizing. And this transformation, I say it's happening now. It's been happening for quite a while. And so and of course it has affected some of us earlier and some of us later, but we're all here now. And so to utilize this is just amazing. And so if you all have any questions, Gary.
Hi, Roy. Thank you so much for your incredible insight on the testing in the age of AI. We don't let me check if we have some questions here now. No. Okay.
I see
Here,
one.
there's one question. Yes, I see one. Yes, too. Okay. Roy, is fully autonomous? Can you see it?
Yes.
Can you check it? Okay. Can you answer that?
Yes,
please?
I can add it.
Okay.
So the question is
Please.
fully autonomous agent-based test automation realistically achievable today or near future? And which set of tools are leading this shift? Well, I will have to tell you, I'm going to start with the tool that our guys are trying to achieve this with, right? And so we have an enterprise version of Claude, and I got to tell you that Claude is really extremely valuable to us. And so I don't believe being fully autonomous will ever happen, because that means we're not needed. Humans aren't needed. So as far as testing and validation, testing can become almost 100% autonomous. But as far as validation and validating in all the areas, right? We're pretty close. We're pretty close, but I don't believe it's ever happening. But there's a lot of tools. But one of the things that we've been leaning heavy into is Claude for much of our testing processes to layer on top, and that's what has helping. And so you have somebody else has a question.
Yes, another question, please.
Looking 3 to 5 years ahead, how will TMMI evolve or extended to ensure test maturity keeps pace with AI's velocity while maintaining trust and transparency? Well, part of what I spoke about earlier is regression testing, right? We can never not do regression testing as applications change, and then the hardware that those applications sit on. And as far as how TMMI will evolve, I believe strongly that TMMI will continue to evolve, and the support that it provides to the industry, I think, is just it's amazing. And so I believe it will definitely continue to evolve, and I believe it's part of the industry that will continue to keep pace with everything that is going on with testing and maturity, so that it can be a leader as it is today.
Okay, guys, any other questions, please just ask. We still have 3 minutes. Okay, Roy, I have a question.
Yes.
In your experience or in your projects that you have done with AI now, testing with AI, do you have an idea or a percentage, a statistic, how much in percentage the human in the loop is involved?
So the human in our experience with what we've been doing lately, Gary, is that we have to be in the loop to oversee it all of the time. So, however, just like building a test plan, now much of that can be automated. So perhaps we don't have to have as many meetings. Perhaps we don't have to have as many people in those meetings, right? And so, but still, the human touch has to remain on top of that testing, no matter what. And everything we're doing with AI, I feel that way about AI altogether, right? Just like the autonomous cars that are out there driving here in the United States. I don't know what's going on in the rest of the world, but here in the United States, these autonomous driving vehicles, right? Even if someone's not driving, someone has to be overseeing those, right? Like back at home base or wherever the data center is, it's managing those vehicles, someone has to be watching. So I don't think it's going to be any different in any other industry, that someone has to remain watching so that they can intervene as soon as something may go wrong.
Yes, at some level, yes.
Yeah.
Okay, thank you. So we are on time now. Thank you, Roy, for this very insightful knowledge that you shared with us. Thank you, people, for joining us.
Yes, thank you all. Thank you all for
Thank you.
For listening.
Okay, thank you.
Thank you, Gary.
Well, a pleasure.
Mm-hmm.